Now it is visible, dear students.
No, sir.
No, sir.
Okay, just overall I will tell about the second criteria. There's a depend upon the complexity and then performance. Please hold on. 1 minute. Check it. Shit. Now it is visible. Okay. See here.
Yes, sir.
You see here the second classification is based on the complexity and then performance. Okay. Here there is a three. In that also there is a based on the three factors. One is a small scale, medium scale, and then large scale. Okay. You have three is there on the complexity and performance. There is the first one is a small scale embedded system, medium scale embedded system, and then large scale embedded system. Coming to the first small scale. See in the small scale, in this small scales, the simple in application is needed. Okay, only simple in application needed, and then performance not time critical. Okay, the performance not depend upon the time criticals. Okay, there's a one thing here in the small scale embedded system, and then it will be built around a low performance and low cost. Okay, 8-bit or 16-bit microprocessor microcontrollers. Okay, there's a example with the electronic toy. Okay, there's a small scale embedded system. It can use for this small scale will be a very simple is needed, and then this is not depend upon the time. The performance is nothing but efficiency. You can also call it efficiency. That efficiency is not depend upon the uh, time. And one more thing, this small scale embedded system will be built low for performance and also low cost, 8-bit or 16-bit microcontroller and microprocessor. Example will the electronic toys. Okay, the electronic toys, if you see the electronic toys, okay, they perform one task, either move or back or front, it moving back or moving front or the left right. Okay, like electronic cars or they're not toy cars. Okay, there's a one simple embedded system. Okay, see that performance is not depend upon the critical, it's not depend upon the time critical. Okay, that's why it is very simple application needed, and it will be performance will be low. As usually the performance will be low, and also the cost also goes on less only, and that inside the electronic toys or any small scale embedded system having a 8 or 16-bit micro processor and microcontrollers. Okay, and second is the small scale. I thought then you go for the medium scale. You see in the medium scale, what is this? Slightly complex in hardware and software requirement. Okay, primary is nothing but software requirement. Okay, it is a compared to the previous small scale. Will here in the medium scale, it is slightly complexity will be there, complex in hardware as well as the software also require will be slightly higher compared to the previous small scale. Okay, here in this embedded system, the medium scale embedded system, it will be built around medium performance. It will be medium performance and also low cost, and 16 or 32-bit microprocessor and microcontrollers. Okay, there's a, and as usually in the medium scale, usually contain the some of the simple operating systems. Okay, for to perform the particular task, they require some simple kernel operating systems for the particular medium scale embedded system. Here we can example is the industrial machines. Okay, industrial machine. Okay, if you go for the in the industrial machine, what happens? There's a number of machines are there, motors are there. Okay, CNC machine, go for a CNC machines. You go for some automation machine. What happens? Each motor will be operating the particular direction, particular rotations, particular speed. Okay, particular stop, particular time will stop, particular time will be on. Okay, these things is okay. These things we can call as the drives. Okay, here in the drives, there's a AC or DC drives will be there. Okay, that will be built for this kind of medium scale embedded systems. Okay, it is having a 1632 microprocessor microcontrollers. Okay, here we are creating a program to operating the, and also it contains small operating system for performing the various tasks in the particular machines. Okay, if you go for DC machine or AC machines, okay, DC drives and AC drives will be the every time what happen, it is in real time operations. The time will be critical here in this medium scale embedded system. It means that every time they're monitoring the frequency and voltage based on the variation of the frequency and voltage, the motor will be operated. There's a one kind of functioning and done by this medium scale embedded systems. Okay, that's why they can use for the industrial machines. And finally, the large scale embedded system. Okay, in the large scale embedded system, as usual, the complexity will be more. Hardware and software, the high complexity hardware and software will be there, and this thing will be built around the 32 or 64 bit RISC microcontroller and microprocessor or PLD, program logical display, or multi-core processor. They can use for this kind of large scale embedded systems. Okay, and it is a response in critical time. It is a response in a critical time. Example is given: mission critical applications. Okay, mission critical application they can use for this type of system. These are large scale systems. Okay, means high performance required. The demanding based on the mission critical application demanding high performance. Okay, this can this large scale embedded system will be employed this machine employed in a mission critical application. Okay, because of it is mission critical application, nothing but it demanding the high performance. As usual, large scale embedded system performance will be very high compared to the previous two types. Okay, and also usually it will be built around 32 or 64 bit RISC microprocessor and microcontroller, and then also called as a PLD. There's a program by using PLDC also you can build this large scale embedded system or multi-core processor. We can use multi-core processor also. We can build a embedded system. Okay, and then one more important thing here introduced in this large scale means this one. They're using the cryptographic functions are used to encode and decoding the media. Okay, cryptographic function means the security of the data. Security of the data will be done by using the cryptographic function will be implemented in this large scale embedded system. Okay. Okay, these are three different. There's a three scales are there in the complexity and performance classification based on the complexity and performance. We have three scales: small, medium, and then large scale. Okay, any doubt regarding this? Any doubt regarding this?
No, sir.
Okay, see, these are the very general information about the classification of the embedded system. Okay, clear? Then the third one is the first one is the generation is over, second one is the complexity and performance, and third one is the behavior based on the deterministic behavior. Okay, see, based on the deterministic behavior. See here in this classification is applicable for real-time system. Okay, what type of this one embedded system are using for this kind of this classification? Okay, that embedded will be means that can be used for the application for real time. Okay, weather monitoring irutte. If you go for the some governments organizations and every time update ಆಗ್ತಾ ಇರಬೇಕು ಡೇಟಾಗಳು ಅಲ್ವಾ, ಅವಾಗ ಈ ತರ ಎಂಬೆಡೆಡ್ ಸಿಸ್ಟಮ್ ನ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ. ಓಕೆ, ಡಿಟರ್ಮಿನಿಸ್ಟಿಕ್ ಬಿಹೇವಿಯರ್ they can means real time it would be operated. Okay, this classification is applicable. This classification is applicable for real time system. See the task execution behavior. The task execution behavior for an embedded system may be deterministic or non-deterministic. Okay, clear? The task execution behavior for an embedded system, it may be a deterministic or non-determination, but based on the execution behavior, real-time embedded system are divided into hard and soft. Okay, hard real time, otherwise soft real time. Okay, it means here in this classification, what happen? This kind of classification of embedded system they can use for the real time application only, real time system only, because of it every time should be getting the data, transmitting, receiving the data, everything. I mean the performance should be deterministic, very high for this kind of embedded systems. Okay, and then next is the final classification is the triggering. Triggering means active, reactive, active and reactive. Okay, the embedded system which are reactive in nature can be based on the triggering. Okay, based on the event triggering or based on the time triggering. Andre ಅದು ಯಾವ ತರ ನೀವು ಎಂಬೆಡೆಡ್ ಸಿಸ್ಟಮ್ ನ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬೇಕು ಅನ್ನೋದಲ್ಲ, ಅದು ಈವೆಂಟ್ ಮೇಲೆ, ಅಂದ್ರೆ based on the event or based on the time consideration. Okay, that will be reactivated the system. Okay, which are reactivate in the nature could be based on the triggering. Okay, reactivate ಈಗ ಇವಾಗ ಆನ್ ಆಗಿರುತ್ತೆ, ಮತ್ತೆ ಇನ್ನೊಂದ್ಸಲ ಆನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಒಂದು ಟೈಮ್ ಕೊಟ್ಟಿರ್ತವಲ್ಲ, ಯಾವ್ದಾರ ಒಂದು ಈವೆಂಟ್ ಈವೆಂಟ್ ಕಂಪ್ಲೀಟ್ ಆದ ತಕ್ಷಣ ಟರ್ನ್ ಆನ್ ಆಗ್ಬೇಕು, ಇಲ್ಲ ಟೈಮ್ ಆದ ತಕ್ಷಣ ಟರ್ನ್ ಆನ್ ಆಗ್ಬಿಡ್ಬೇಕು. ಓಕೆ, ದಟ್ ಆಲ್ಸೋ ಕ್ಲಾಸಿಫಿಕೇಶನ್ based on the classification will be based on the triggering. Okay, it may be event triggering or it may be time triggering. Okay, it means that the embedded system which are reactive, okay, it is be activated next cycle. Okay, based on the time or is based on the event triggering, reactivating the system. Okay, ಈಗ monitoring ಆಗೋಯ್ತು. ಈಗ every second we can monitoring the weather or temperature. Okay, first you detect the temperature. After that, in next second reading will be taken for which based on the event or based on the time. Okay, we are given the reactivating the triggering the embedded system by adapting this time triggering or then event triggering. Time triggering every 2 seconds. Okay, should take the reading, then that is a time triggering. Event triggering andre enandre after completing one cycle, the next cycle banta takshana event, that one event will be complete, another event banta takshana it will be trigger. Okay, that is the reactivating the embedded system based on the triggering. Okay, it may be event triggering and then it may be a time triggering. Okay, see, these are the very important classification based on the classification of the embedded systems. Once again I repeat that one. The classification of embedded system will be based on the some of the following criteria. We have 4 criteria are there. One is the on the generation, on the complexity and performance, on the deterministic behavior, on triggering. Okay, coming to the generation, we have 4 generation is there: first, second and third and fourth. Each generation having a different build, and also they can use the different hardware and software frameworks, and also they can use the different applications. So if we go for the first generation, what happened? It built around a 8-bit microprocessor microcontrollers, and it is a simple hardware and software implementation they can use. For the example will be the digital telephone keypads. And second generation, again it is built around 16-bit microprocessor microcontrollers, 8-bit microcontrollers. It will be more complexity and powerful than the 1G microprocessor microcontroller. Example is the SCADA system. And third generation, it will be built around the 32-bit microprocessor and 16-bit microcontroller. And here in this we are introducing the digital DSP, digital signal processor, or application specific integrated circuits are introduced in this third generations. This third generation embedded system can use for the robotic or media sectors. And fourth generation, it will be built for 64-bit microprocessor and 32-bit microcontrollers. Now they introduce the it will be the concept of this SoC. There's a system on chip, and also the multiprocessor evolved, and as usual complexity will be more, and it's also very powerful. Example is the smartphones. And also this embedded system classification on based on the complexity and performance. You have three classification is there in the complexity and performance: small scale, medium scale, and then large scales. Okay, in the small scale, simple in application needed, performance is not time critical, it is built around low performance and low cost 8 and 16-bit microprocessor microcontroller. Example will be given is the electronic toys. And then coming to the medium scale, slightly complex in hardware and software requirement. It is built for the medium performance and low cost 16 or 32-bit microprocessor and microcontroller. And this small medium scale, it contains some of the small operating system. Example is the industrial machines or industrial automations. And finally, the last scale is the large scale. Compared to the medium scale, it is a high complex hardware and software. It is built around 32 or 64-bit PLDs, multi-core processor or RISC microprocessor microcontrollers. Okay, it is a response in time critical. Example, mission critical applications. Okay, these are the sub classification of the composite and performance classification of embedded system. And next one is the deterministic behavior. Okay, this classification based on the is applicable for real-time systems. Okay, then task execution before an embedded system may be deterministic or non-deterministic, but the execution will be based on the behavioral real-time embedded system. It may be divided into odd real-time or soft real-time system. And finally, the last classification is the on triggering. Okay, the embedded system will reactivate in nature, can be based on the triggering. It may be event or it may be a time trigger. Okay, these are the most 4 important classification in the embedded system. Okay, any doubt regarding this? Any doubt?
No, sir.
No doubt, sir.
Answer attendance. See, all of you paid the fees. All of you paid the fees. ಎಲ್ಲರೂ ಮಾಡಿದ್ರಪ್ಪ ಫೀಸ್? ರಮೇಶ್ ಫೀಸ್ ಕಟ್ಟಿದ್ರೇನೋ? ಸಿ ಎಲ್ಲ ಕಟ್ಬೇಕಪ್ಪ ಫೀಸು. ನನ್ಗೆ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ರೆಸ್ಪಾನ್ಸ್ ಮಾಡಿ, ಯಾವಾಗ ಕಟ್ತೀರ ಅಂತ ಇಮಿಡಿಯೇಟ್ ಆಗಿ ನನ್ಗೀಗ. ಹಾ, 18 US number 18.
Yes, sir.
ಜಯವರ್ಧನ್ ರೆಡ್ಡಿ.
Yes, sir.
ಫೀಸ್ ಎಲ್ಲ ಕಟ್ಟಿದ್ಯಾನಾ?
Yes, sir.
ದಿಲೀಪ್ ಕುಮಾರ್ 28 US number 28. ದಿನೇಶ್ 29.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ನೀನ್ ಫೀಸ್ ಕಟ್ಟಿದ್ಯಾನಾ?
ಸರ್ ಅದು ಲಿಂಕ್ ಕಳಿಸ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್ ನೀವು ಅವತ್ತು.
ನೀನ್ ನನ್ಗೊಂದೀಗ ಒಂದು ಮೆಸೇಜ್ ಮಾಡು, ಇಮಿಡಿಯೇಟ್ ಆಗಿ ಕಳಿಸ್ತೀನಿ.
ಓಕೆ ಸರ್.
ಓಕೆ, ನೆಕ್ಸ್ಟ್ ದೀಪ್ಚಿ.
Present, sir.
ಅಭಿಷೇಕ್ ಎಸ್. ಅಭಿಷೇಕ್. ರೂಪಶ್ರೀ. ಸುಬ್ರಹ್ಮಣ್ಯ ರೆಡ್ಡಿ. ಸುಬ್ರಹ್ಮಣ್ಯ ರೆಡ್ಡಿ. ಸೋನಿಕಾ. ಶ್ರೇಯಾ. ಜ್ಯೋತಿ.
Present, sir.
ವೆಂಕಟ್. ಎಲ್.ಎನ್. ಮೂರ್ತಿ. ರಮೇಶ್ ರೀ.
Yes,
ರಮೇಶ್
sir.
ರೀ, ನಿಮ್ದು ತುಂಬಾ ಇದೆಯಲ್ರಿ ಫೀಸ್, ತುಂಬಾ ಜಾಸ್ತಿ ಇದೆಯಲ್ರಿ, ಯಾವ ಕಟ್ತೀರಿ
ಇಲ್ಲ
ಪೇಮೆಂಟ್? ಹಾ
Sir, ಅದು ಸ್ಕಾಲರ್ಶಿಪ್ ಬಂದ್ರೆ sir.
ಅಲ್ಲಪ್ಪ, ಸ್ಕಾಲರ್ಶಿಪ್ ಎಷ್ಟು ಕೊಡ್ತಾರಪ್ಪ ನಿಮ್ಗೆ?
64.
ರಿಮೈನಿಂಗ್
15,000 ಇದೆ ಸರ್.
ಕಟ್ಬೇಕಲ್ಲಪ್ಪ?
ಹಾ ಸರ್.
ಯಾವಾಗ ಕಟ್ತೀರಾ?
ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಸರ್.
Okay. And then Srinivas, answer attendance, Srinivas. Okay. Okay, dear student, today we'll stop here.
Sir,
We'll continue. Yeah, tell me.
Rupashri is present, sir.
Okay. ರೂಪಶ್ರೀ.
Yes, sir.
Okay. Okay,
Sir.
dear student. Yeah, tell me.
ಸರ್ ಅಸೈನ್ಮೆಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟೊಂದು ಆನ್ಸರ್ ಸಿಕ್ಕಿಲ್ಲ ಸರ್
ಹೌದಾ?
ಆರ್ಮ್ ಅಲ್ಲಿ
Module 2 ಅಲ್ಲಿ ಸರ್.
ಮಾಡ್ಯೂಲ್
ಹೌದು.
ಸರ್
Okay, ನೀವು
Sir,
ಐಡೆಂಟಿಫೈ ಬುಕ್ ರೆಫರ್ ಮಾಡ್ಬೇಕು.
ಸರ್ ಬುಕ್ ಅಲ್ಲಿ ನೋಡ್ದ ಸರ್ ಬುಕ್ ಎಲ್ಲ ಚೆಕ್ ಮಾಡಿದೆ ಸರ್ ಅದ್ರಲ್ಲಿ ಆನ್ಸರ್ ಸಿಕ್ಕಿಲ್ಲ ಸರ್
ಹೌದಾ? ನಾನು ಕೊಡ್ತೀನಿ ಬಿಡಪ್ಪ. ಓಕೆ, ಅವನು ಪ್ರಾಬ್ಲಮ್ಸ್ ಮಾತ್ರ ತಾನೆ?
ಇಲ್ಲ ಸರ್, ಬೇರೆ
ಸ್ವಲ್ಪ
ಥಿಯರಿ
theory
ಕ್ವಶನ್ಸ್
ನೂ ಅಷ್ಟೇ
ಸಿಕ್ಕಿಲ್ಲ
sir.
ಸರ್.
ಥಿಯರಿ ಕಳ್ಸಿ ನನ್ಗೆ ಯಾವ್ದು ಅಂತ ನಂಗೆ ಮಾಡಿ ಕಳ್ಸಿ. ಇದು ವಾಟ್ಸ್ಆಪ್ ಮಾಡಿ ನಾನು ಕಳಿಸ್ತೀನಿ.
ಓಕೆ ಸರ್.
ಓಕೆ
ಓಕೆ ಸರ್.
ಸರ್ ಹಂಗೆ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಲಿಂಕ್ ಅಪ್ಲೋಡ್ ಮಾಡಿಲ್ಲ ಸರ್ ಅಸೈನ್ಮೆಂಟ್ ಲಿಂಕ್ ಆರ್ಮ್ DSS ಮಾತ್ರ ಅಪ್ಲೋಡ್ ಆಗಿದೆ ಆರ್ಮ್ ಅಪ್ಲೋಡ್ ಆಗಿಲ್ಲ ಸರ್
ಪರ್ಸನಲ್ ಇದು ಹಾಕ್ತೀನಿ ತಡ್ರಿ. ಒಂದು ಗೂಗಲ್ ಫಾರ್ಮ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿ ಅಲ್ಲಿ ಅಪ್ಲೋಡ್ ಮಾಡಿ.
ಓಕೆ ಸರ್
ಅದರ್ವೈಸ್ ನಾನು
Okay,
ಅಲ್ಲೇ
sir.
ಹಾಕ್ತೀನಿ.
ಓಕೆ ಸರ್.
ಸಾರಿ, DSS ಅಲ್ಲಿ ಅಪ್ಲೋಡ್ ಮಾಡ್ತೀನಿ. ಆರ್ಮ DSS ಅಪ್ಲೋಡ್ ಆಗಿರೋದು?
DSS
ಅಪ್ಲೋಡ್
ಆಗಿದೆ
ಆಗಿದೆ
ಸರ್.
ಸರ್
ಆರ್ಮ್ ಇವತ್ತು
ಆರ್ಮ್
ಅಪ್ಲೋಡ್
ಇಲ್ಲ ಸರ್
ಒಂದು 4 days ಕೊಡ್ತೀನಿ ಟೈಮ್, ಅಪ್ಲೋಡ್ ಮಾಡಿ. ಓಕೆ,
ಓಕೆ ಸರ್
ಥ್ಯಾಂಕ್ ಯು ಆಲ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್
ಥ್ಯಾಂಕ್ ಯು ಸರ್.